Data analysis in the biomedical and healthcare fields is a strategic discipline aimed at transforming large volumes of information into useful knowledge for clinical, research, and organizational decision-making. Situated at the intersection of engineering, medicine, statistics, and technology, this process integrates techniques ranging from classical statistical analysis to advanced signal processing and machine learning. Within this framework, data can be classified as qualitative and quantitative, each with specific characteristics that determine its methodological treatment. In fact, qualitative data, whether nominal or ordinal, allow for the understanding of contexts, experiences, and clinical categories, while quantitative data, continuous or discrete, enable the objective measurement of physiological variables, laboratory results, or healthcare events. To ensure the reliability of the results, the analysis requires a prior pre-processing process that includes data cleaning, transformation, and reduction, tailored to the nature and purpose of the study. In turn, missing data management, noise reduction, normalization, feature selection, and dimensionality reduction are essential steps to ensure the quality and consistency of the dataset. Ultimately, the use of specialized tools and programming languages geared toward data science facilitates the systematic exploitation of information, solidifying data analysis as a fundamental pillar for innovation, improved diagnosis, and the development of advanced solutions in the healthcare sector.